Good evening, everyone. I welcome you all for the fifth day of Faculty Development Program on this recent advance and technologies in electrical engineering, a research perspective. I feel very happy to introduce our today guest speaker, Mr. S. Selvakumar. He has completed his BE in Electrical and Electronics Engineering at RDS College of Engineering and Technology. He has completed his Masters in Power System at Anna University, and also he got gold medal for his Masters from Anna University. He has worked as engineer at Power System Studies in Power Research and Development Consultants (PRDC) Private Limited from 2006 to 2008. From 2008 to 2011, he served as electrical engineer in Tata Consulting Engineers Limited, Bangalore. He is associated with ABB Global Industries Limited, Chennai from 2011 to 2019 as lead engineer. In 2019, he joined as head engineering and design at Power Projects, Chennai. He has handled many projects: Tata Steel 10 MTPA expansion, power evacuation studies for the rain in southern grid, impact of monopolar operation of Talcher, Kolar HVDC. He is involved in many prestigious projects, including Mudra 4000 megawatt UMPP, actually first in India. He has involved in designing the power systems of many steel, cement, power, paper industries, commercial buildings, power plants, and substations. In ABB, he has completed many challenging assignments, including 570 MVA three-phase, three-winding transformer designed for combined cycle plant in Bangladesh, designed 120 megawatt combined cycle plant in Indonesia, and so on. His international exposure includes Germany, Italy, Bangladesh, Singapore, Malaysia, Qatar, Kuwait, Dubai, Australia, Sweden, Canada, Philippines, Thailand, and so on. He is associated editor for journal Transaction on Engineering and Science. He is also industry experts on power system control and production. He has guided many projects for electrical students in bachelor level and master level. He has conducted seminars, workshops in various academic institutions and industries. His area of interest are microgrid, energy storage, electric vehicle infrastructure, grid planning, power system operation and control, production, power plant and substation design, integration of renewable system studies and smart grid. Here I give you a very short introduction about our guest speaker. Now I would like to invite our resource person, Mr. S. Selvakumar, to take over the session. Welcome you, sir.
Thank you. Thanks a lot, sir, for your warm welcome. And it's my pleasure to be part of this 5-day event. And day 5, the last day is always important for the very simple reason because it's the day where we conclude the learnings of all the 5 days. And means I have limited time, so without wasting time, straight away let me jump into the presentations. And the session is yours. I strongly believe in it, all my sessions. If you have any questions, clarifications, please feel free to stop me then and there. I mean, either in the chat box or unmute yourself, post the questions. I strongly believe learning is more important than what I am delivering. So that's to the audience, both in Google Meet as well as in the YouTube. I could see there are people joining from YouTube as well. So I believe my screen is visible. Can you just anyone confirm that you're able to see my screen?
Yes, sir. It is visible,
Yes, sir. Yes, sir. You can proceed.
Perfect. Always the advantage of coming on last day is that means the people, those who are not aware of this Google Meet, how to use, how to pin, etc., might have understood in all the 4 days. Yes, thank you. So it's me. I have to thank King's College of Engineering and Department of EEE, and thanks to HOD sir for giving such a wonderful opportunity to talk about role of energy storage in this 5-day event. This is what my agenda which I have planned. Rather than jumping directly to the discussions of what I have to deliver, I thought of refreshing what we have learned in the past 4 days in maybe 10 minutes, not 10 minutes, maybe 5 minutes because of the time. Let's cut short it to 5 minutes, but let's refresh what we have learned in the past 4 days. Then let me quickly introduce about me, that I think there is a fabulous introduction. I don't want to waste my time. Maybe let me talk only 1 minute about my organization. Then we talk about present and future power system scenario. That's, let me talk about 15 minutes. And the need of energy storage. That's what my topic. Let's talk about 15 minutes. So like present and future scenario basically talks about um, uh, a context of my session, that is why do we need to learn this subject, and the need of energy storage, that's going to set a content of what I need to deliver. And the question and answers I have allotted for 12 minutes or even more than 12, that's approximately, you can take 15 minutes. And means this is not necessary has to be at the end of the session. At any point of time you can post your questions. You can your questions are always welcome at the middle, and if I am not watching the chat box, probably you can unmute yourself and you can post the question as well. So let's quickly jump on to this. What we have learned, what we will learn, what we will learn, that leave it for the last 40 minutes. But what we have learned, that's most important. Day one, we have started with an interesting topic on recent trends in electric vehicles. So I strongly believe, means what's the EV is the future, but it is also equally important to understand where we stand. Any quick guess how many electric vehicles are sold in the last year? That is 2019. Any guess? I'm okay with if you're putting the answers in the chat box, or I'm okay with also if you're sharing the answers by means of unmuting yourself. I'm okay with both, but I don't want this session to be a one-way communication. So let's have, means what to say, to the best possible the interactive sessions. If you have an answer, how many electric vehicles which we have sold last year? Any quick guess? I have to ask a question like this. Then, what's the outcome which you have derived on day one? I mean, what you have learned on day one, recent trends in electric vehicles. Maybe we don't have enough time, so I expect very quick, fast response, maybe 1 minute per topic, so that we can finish it 4 minutes, 4 topics, then we go to our session. Any quick answers? No answers? And look at the chat box. Yeah, BMS system. Thanks, Kesav Prabhu, for putting the answer. BMS system and charging advancements. That's great. Yes, but that's great. That's what you have learned. But question is, how many electric vehicles are sold in the last year? By 2030, completely electric vehicles. That's great, sir. I do not know that will happen in India or not. The expected projection says that means 2030, we have about 30 percentage of 40 percentage of the vehicles will move to the electric vehicles. That means selling again, not even this. So let's quickly give an idea of where we stand today. Yes, I mean, let me tell something which you really don't want to see. Right, just a minute. Hope the screen is visible. My second screen is visible, I believe. Am I right? So this is the vehicles which are sold in April to November in 2019, which you can see. I'll go to the other things. I mean, we have sold about 1.56 lakh units in 2019 to 2020. That's majority of two-wheelers. Means you can see out of 1.56 lakh, it is 1.36 lakh. That is last year. Means 1.56 lakh. Hope you are able to see my screen, right?
Yes, sir.
Yes. Yeah. Thank you. So 1.56 lakh is what the vehicles which has been sold in the 1920, that is a financial year. So I mean that is slightly better compared to the previous financial year 18 and 19. But even if you look at 1.56 lakh vehicles, I mean, so to say, predominantly we have sold two-wheelers, that is 1.52 lakh, and 3,400 cars and 600 buses. This is what our benchmark in the year last year, right? So probably means what to say, if you look at including three-wheelers, that is huge, but three-wheelers are mostly of lead acid. So this is EV, not necessarily two-wheeler or four-wheeler. This you might have seen. You can even watch this video in YouTube. I will share that in the chat box. Not necessarily now, at least probably you can watch that. Yes, But auto sector, yes, there is some chat box. Auto sector is declining. That's simple reason because they have tried with lead acid battery, but lead acid battery is the not right battery for the electric vehicles. Yeah. So means EV, not necessarily we have to think of two-wheeler or four-wheeler. You can look at this also. So that I thought of just giving, yes. And why I am touching this EV to this extent is EV is mandatory, no doubt about that. But if you charge your vehicle with, I mean, electric, but that energy is generated from a fossil fuels. That means instead of burning a diesel in the car, if you use a diesel generator to generate the electricity, what is the use of it? I felt that's more relevant to the topic, and if that energy storage means plays a key role in integrating renewable. So I think I am able to connect this EV with the renewable energy. Sorry.
Sir, PPT not visible.
Okay, done. Okay, fine. So let me.
Sir, it is visible, sir. You just maximize the screen, sir.
Okay. Is it visible now?
Yes, okay, sir.
Okay, fine. So, is it make sense? I don't think it makes a sense because means if you have, so to say, car and probably if you use this one, means if you have, instead of fueling with a diesel, probably if you get that electric cars, but if you get the energy from the conventional plants, that doesn't make a sense. And we need to move to this place where means we are getting the energy from solar and wind. Are we in what level we are? And if you want to increase this renewable penetration, what we have to do? That's what our topic. I think let me stop that at that place and let me jump to my presentation. I believe, yeah, I think there is some issues which I am facing in the sharing. Yes, I believe now you might be able to see this screen. So yes, I think Ramareddy sir and day one has given some insights of electric vehicles, but it is important you need to understand means where we stand on the electric vehicles. And there is no absolutely no advantage of having electric vehicles and still we power that electric vehicle from the conventional fuel plants, right? Day two, we have understood the role of STATCOM. What you have understood on the role of STATCOM and distribution systems? Any quick answers? Yeah, we are losing always the time, so probably let's quickly get some answers. That's always good. If charging issues are improved, sales may go up. Thanks, Jyoti Patel. Means even I am also hoping that. Yes. Keshav Prabhu has answered on the day two what has happened. Power quality maintenance, compensations. Yes, after pinning, you will definitely get that. Dynamic charging infra has to be developed. Decent, definitely it has to be. No doubt about that, Keshav Prabhu. Yes. So let me go back and talk about this point two, that is role of STATCOM in distribution systems. Role of STATCOM in a distribution systems, we have to define it more clearly. Like in a low voltage, if you take 415 volt, really I couldn't understand the role of STATCOM. Simple reason because so to say we are able to regulate the voltage better, means with the on-load tap changer, and means what to say we don't have such a huge fluctuating loads in the low voltage. So means when we say role of STATCOM or role of SVC, we need to really understand when we say in a distribution system, that is not in a utility distribution system, but that is in a industry distribution system or in a traction distribution systems where this load is fluctuating from 0% to 100% in a very short duration. So if you take electric arc furnace in steel plant, or when you say take a traction loads, the load changes are huge in a very short time. In that time, probably on-load tap changer may not be able to regulate the voltage because it's a physically changing the tap takes time. So you have to appreciate the role of STATCOM in a distribution systems. But when we say in distribution systems, it is industrial distribution systems or probably the traction systems. But I'm looking at this way, STATCOM doesn't have a much role in the utility distribution system. But on the other side, the STATCOM has a huge role to play, in the transmission systems for the voltage regulations or dynamic reactive power compensations, especially for at least large scale wind farms, large scale solar panels, etc. And probably I believe that topic is also more relevant to us, the energy storage. If you talk about the energy storage, everybody talks about the battery energy storage. And StatCam and battery energy storage by power electronics, there is no difference except means what to say on the DC side, if you had a battery or a flywheel or some other device which stores the energy. I think whatever may be the concept which you have learned on day 2 with respect to the StatCam, its architecture, how it regulates the reactive power, etc. The same thing what we are going to see, but only thing, since we have some energy storage device on the DC side, that helps also to regulate or control the real power. So StatCam, I think someone has unmuted. Probably you can mute yourself. Yeah. Yes. Thank you. So the role-wise, the StatCam and the battery energy storage system or energy storage systems, the only difference, StatCam has only a reactive power capability. Hence, it will be able to regulate only the voltage. But this energy storage system has both real and reactive power capability, and more specifically, it has independent real and reactive power capability, and hence we are able to regulate just not the voltage but also the frequency, and that is mandatory when we are going with an intermittent renewable resources, which is wind and solar. Beautiful. So move to the day 3, that is product design and simulation using Arduino. I may not be able to directly relate this product design simulation using Arduino, but I can say role of energy storage. Quite a lot of battery energy storage systems along with the power bidirectional converters which are coming in. Yeah, still I think somebody can mute yourself. Yes, thanks. So what to say, when we talk about this product design, almost what to say, other countries has a lot of things to do. They have done a lot of works already in the product design of this bidirectional converters and the battery energy storage. It's not yeah, any questions? Any questions? Probably you can ask. Yeah. Fine. Yeah, if there is no questions, probably you can mute yourself. Thank you. So product design means we also has to do quite a lot of things with respect to the energy storage product design. That means voltage source converter based bidirectional converter, which converts it controls both real and reactive power in both the directions independently to regulate the voltage and frequency, which also suppress the harmonics against other power electronic devices, which injects the harmonics to the systems, maintains the power factor, maintains the voltage, and probably means there are quite a lot of applications which it has to do. I'm coming to that. So in that perspective, I believe product design is also important, and optimization using multi-objective genetic algorithm. I think that is more relevant, especially when we come to the microgrid. So I think all the 4 topics what we have seen probably can be applied to this energy storage systems when we design an energy storage systems that is operating in an islanded systems or a grid connected systems with a specific purpose. So let's not talk much about me. I think this is my journey. I think 5 different companies logos gives an idea of what are the companies the students can get the core opportunities. These are all the companies which I have traveled. About my organizations, I am heading engineering and design team in power projects, and we have 43 power system engineers, and we have completed about 93 projects in 13 countries, and we have recently, a day before, we have back to 2 more projects. And we work across the sectors. We work in oil and gas, we work in data centers, we work in transmission and distribution, conventional power plants, renewables, energy storage, sports stadiums, shopping malls, auditoriums, theaters, industries, and recently we have backed a Nagpur metro project, so that means we are into traction as well. So this is about a small intro. This is what we do. We are an ideal company for ME power system or power electronics engineers, and we do from all kind of power system studies using the simulation softwares. So we are expertise in the simulation softwares. At least this helps for the participants to understand there are many simulation softwares are available, and the simulation softwares will help you to get into the core companies. I'm not going depth on individual softwares because of time constraints, but you can understand ETAP, Excellent, PSSE, SIME. These are all the softwares that are basically for a power system studies like load flow, short circuit, motor starting, relay coordination, etc. PSCAD and EMTPRV, that's for an insulation coordination or time domain analysis, switching transients, lighting transients, etc. Dialects for lighting design, PVSys for a solar plant design, Homer is basically for a microgrid design. So these are the softwares definitely in your resume. If you're a student, it definitely helps you to enter into the core companies. These are all our prestigious customers and few projects. We have done 1,500 megawatt solar projects in Saudi, airport in Saudi, mall in Qatar. We have done a FIFA World Cup stadium in Qatar, wind farms, means Hero manufacturing unit. This is for a Pepsi food processing industry in Saudi. Yes, I think before moving to the next, let me check any questions in the chat box. Yes, power electronic systems are sources of harmonics. Still, we are handling harmonics in power system with the same power electronic switching. Any alternatives? Active harmonic filter is also a power electronic which suppress the harmonics, Kesav Prabhu, and means we have a similar I mean what to say feature which I am going to come with the voltage source converter, which is used for this system that helps I mean to suppress the harmonics. Suggest with the custom power device is more suitable for reactive power compensation and THD reduction for a solar and wind grid. So we will discuss when we are moving Sarada Devi to talk more on that. Yes, right. I think that's all the questions. Let me quickly move on to means my further slides. I believe still my screen is visible. So let's talk about this present scenario. So yes. So means where we stand. I think I have already opened this corresponding reports. Anyway, this presentation I will share it so that you will get this links also. This is a CEA website, Central Electricity Authority website, which gives what's the total installed capacity as on today. This is an SRLDC website. This gives you information on a daily basis how much energy generated from the conventional plants, how much energy generated from the renewable plants, etc. And this is a POSACO website. This gives a beautiful information after COVID. It means on a daily basis demand, weekly basis demand, all these things across India. And this last important slide means a link which is going to give you what's the price of these renewables compared with the conventional plants. Yes, so quickly I mean rather than clicking the link, I have already stored it. Still, I believe my screen is visible. Hope you are able to see the website. That is a CA website which I am showing. Am I right?
Yes, sir.
Yes, yeah, thank you. So this is one important website, cea.nic.in, which you should not miss really, means as an electrical engineer. It is not visible. Okay, I'm not really in PPT. I'm in the website. Yes, that ca.nic.in, that's the website which I am sharing. So means if you go to that installed capacity, you have, I mean, so let's say monthly wise installed capacity, and from that you will be able to look into what is the, I mean, total installed capacity as on 30 at the June 2020. That means about 17 days back. So if you look at the screen, I mean, so let's say as on today, the total capacity is 371 gigawatt. That is 3,71,000 megawatt. That's total installed capacity. And out of this 371 gigawatt, about 87 gigawatt is renewables. That means if you look at from the installed capacity perspective, 87 gigawatt is the renewable capacity, 87.669 more specifically. That's the installed capacity in gigawatt by renewables, and 371.054, that is total capacity. So if you look at what's the percentage of renewables we have already installed in India, is about 23.627%, right? This 23% is what's the total renewable capacity, what's the total renewable capacity which we have in India. This is only an installed capacity, not about the energy generated. It is only about the renewable capacity. Whether we will be able to get the split up of this renewables of 87 gigawatt, yes, that is possible. That is possible. That's available here. As on today, means as on 30th June, I mean total installed capacity is this much. How much solar, how much wind, how much small hydro, how much bio, all these informations are available. That's in the CEA website, which link I have set in the chat box. Right. So having said that, is it possible to find out the state wise? Yes, you can probably go to the other downstream pages and you can find out the same thing in a state wise like Delhi, Haryana, etc. If you take Tamil Nadu, means what to say, we have already huge installation base of renewables. We have totally about 32,842 megawatt, that is 32.8 gigawatt, out of which about 14.35 gigawatt comes from renewables, that is about 45%. If you look at Karnataka, out of 29.834 gigawatt, they have 15.24 gigawatt from renewables. which means they are already more than 50% of the renewable installed capacity. Again, I am stressing these are all only the installed capacities. These are only the installed capacities, not the energy generated. Obviously, we can understand the difference between the renewables and other sources. If we have wind or solar, the plant load factor is only typically in the range of about 20 to 30%. So the energy generated is not 23%. Installed capacity wise, it is 23%. So let's go on to the something else data. This is a NSRLDC website data, which link I have I'll share along with the slides so that you can get it for the registered participants. So where I am, I have to go to this SRLDC website. This is another interesting website which you should not miss. Southern Regional Load Dispatch Center. You Google it, you will get the frequency. Time is 5:27. You can see that frequency is 49.97 hertz. If you measure frequency at your plug point in your home now with a frequency meter, you will get this 49.97 hertz. Here it's another interesting. Quite a lot of information is available here. If you go to the reports and daily reports, you will be able to get this reports for the past 16-17 years. All this data like power supply position, generator outage, transmission line outage, all this data. If you look at this power supply position, means this is southern regional, so means you will be able to find out only for southern region. Similarly, you can go to western region or eastern region to find out the corresponding states. So since this is southern region, I am just focusing at Tamil Nadu. Yesterday, how much energy which we have generated from different sources, if you look at, means we have generated only 43.18 million units. That is, you know what is unit? 1 unit is 1 kilowatt hour. Million units means 10 power 6. So we have generated yesterday 43.18 into 10 power 6 kilowatt hour from thermal. Means 11.78 from hydro, 7 from gas, diesel, naphtha. But whereas we have generated 72.69 million units from wind. That means if you look at yesterday, this is peak wind season for us. So yesterday alone, we have generated about 72.69 million units of electricity from the wind. That is comparatively higher than any other sources, correct? No? The total itself, 111. So out of which 72, that means yesterday, if you look at, means what is it? Tamil Nadu has about, means what is it? More than 70% of the energy is made by renewables. Right, means we have only a very small percentage from others. So we have this is a beautiful wind season for us. So similarly, you can compare for Karnataka. Karnataka has 35 million units from wind, 14.88 million units from solar. Compared to this thermal, means they have a beautiful hydro potential. You can look at means what to say. Means along the total, it has a very small fraction of percentage which is coming from thermal. Apart from that, almost they're generating the energy from the renewables. So this is another website which you need to really look into. The third website which I am going is this POSACO website. They are responsible for operating this system. So you can just Google it with POSACO COVID. Means they came up with a dedicated page for this COVID-19 after that. They have quite a lot of data from March 22nd, day-wise, week-wise, they are giving the data. So means this is a typical week-wise comparison which you can find. Means how this demand is changing weekly, daily, etc. So they have also given day-wise demand at last and region-wise. Probably if you take a data like 5th July, the total demand of India on the entire day of July is 3,304 gigawatt hours. 3,304 gigawatt hours is what's the total demand or total energy consumed in India on 5th July. Let me putting back into the Excel sheet. That's what here I have done precisely. 3,304 gigawatt hours. If I divide by 24, then I will get the gigawatt. That's the demand. This is an average demand. So approximately 137 gigawatt is an average demand on that particular date. That is on 5th July. So these numbers are quite less. Simple reason because we are in a lockdown. Generally means what to say, we have hit about average of more than 150 gigawatt, and the peak demand is about 200 gigawatt. I think in the same CA website, I have shown the installed capacity is about 370 gigawatt, right? So 370 gigawatt is what is the installed capacity we have. But the peak demand what we are able to meet or what we have is only 200 gigawatt. That means we have an abundant installed capacity higher than the demand. Even if you assume this 87 gigawatt, which is intermittent in nature, still means what to say, we have a far better installed capacity to meet the peak demand. Yes, so maybe before I'm going for, let me take if there is any questions. please, in the chat box. Yeah, PPT is not visible. I came back to the chat box. That might be the reason it is not visible. If it is not visible, probably you pin my name. You will get either PPT or where I'm going towards. Yes. Right. Done. So let me, move on further. Let me talk about the final interesting data which we have from this data of lost information. That is, recently SECI, Solar Energy Corporation of India, came up with the data. I will share the links in the chat box. No doubt about that. I will do that. All the links I will share it in the chat box. Anyway, I will share the slides so you will be able to get that. Not an issue. I think somebody else started presenting it. Probably you can stop it. Yeah, thank you. Fine, I have shared the link, right? I'm coming to the last important point of what's today's topic, why it is relevant. Means recently, SECI, Solar Energy Corporation of India, has floated a tender for 1.2 gigawatt renewables with an energy storage to provide a firm power on the peak hours. As you know, means solar is cheaper nowadays, and probably it is much cheaper than the cost of energy from thermal. Thermal costs approximately from 3.5 rupees to 4.5 rupees, but solar you will be able to generate the electricity from much less than 2 rupee 50 paise. And Greenco and Renew, the famous contractors in India, won this 1200 megawatt tender from SECI. 900 megawatt goes to Greenco. They are putting renewables plus pumped hydro. That means still pumped hydro is on with respect to the energy storage. So energy storage doesn't mean something new, great technologies. It will be conventional pumped hydro, which is already existing for years. And the Renew is going with the 300 megawatt, and they are putting up a battery energy storage. But that's all not interesting. The interesting fact is like the tariff. I mean, what do you say? Greenco has backed 900 megawatt. They are going with the peak tariff of just 6 rupee 12 paise. That means they have providing not an intermittent power. Let me not talk about intermittent power. They have a renewables, but they have to give a firm power. That means they need an energy storage. That means this energy storage plus renewable is almost close to behave as a controllable source like your thermal plant or gas-based plants. And they are able to bring down that price to 6 rupee 12 paise. That means that's a great news. So Renew Power is going with 300 megawatt with the battery energy storage, and their tariff is 6 rupee 85 paise. This is definitely comparable or in par with the conventional sources, right? And probably means battery technology is maturing and the cost of the battery is coming down. And in a near future, we will be able to reach a point where the renewable plus energy storage might look even cheaper than the conventional plants. That's where we are heading towards. Right, I think that's with that information. Let me move on. Yeah, means any questions? I'm happy to take before we have going to the other sessions. Any questions? Even if you want to unmute yourself, yes, you can do that. What's the development of energy storage from last decade to recent? Are you sure the recycling is completely available for chemical e-waste of BMS? Yeah. Yes, we will take up that question along my session, Kesav Prabhu. Thanks for putting a very interesting question. Yes. So then probably if there is no questions, I will answer the Kesav Prabhu's question along with my last way of presenting it. That's about this. Yes. Energy storage. Energy storage not necessarily has to be battery energy storage. It can be anything. It could be like mechanical. When we say mechanical, it could be a pumped hydro, compressed air, flywheel. Means we also need to understand the fact what kind of energy storage, where do we need to use. If you want to use high power for a short duration, then probably you can go with a flywheel. If you want to use high power for a longer time, then you have to go with a pumped hydro. Similarly, you have an option like thermal, molten salt. You have electrochemical, that's batteries. Electrical, we have supercapacitors. Supercapacitors are again, I mean, high power but low energy. That is a very short duration. Chemical, you have like hydrogen fuel gas, etc. So this is, I mean, it's not necessarily energy storage. We need to think of battery energy storage. It could be any form. But I mean, as on today, when we say talk about energy storage, I mean, battery energy storage has an edge over other things, and that has commercially, comparatively, I mean, what to say, has an edge also to other technologies. That's why reason why every people's now when they talk about energy storage, they really relate it to the battery energy storage. This is a typical example of what you need to choose. Depends upon your means power and the duration. As I told, pumped hydro is for a large power for a longer duration. It depends upon the power and time. You can choose a different means devices to store the energy. This is what my probably interesting topic. Why do we need energy storage when we talk about this renewables? So let me take about a simple example of like this. Assume that this could be even a college where it receives a power supply from the electricity board and uses a step down transformer to step down to 400 volt, and it is feeding the loads. Assume that this college, or this could be, you can relate it as a hospital, or this could be related to a data center. You can treat means any applications, receives a power supply from utility and step down and feed the loads. And you have a critical loads also here, like data centers, hospitals. Definitely there will be critical loads, and even for a college you may be having some labs, etc., which has critical loads, right? So assume that in order to reduce the electricity tariff, right? It means if you take Tamil Nadu, it means our commercial tariff is about 8 rupees and industrial tariff is 5 rupees and plus demand charges. Anyway, means if you're in industry or commercial, means your energy charge is more than 6 rupee or 6 rupee 50 paise. So solar or wind works much cheaper compared to this energy from the electricity board. So definitely the industries or commercial buildings to think to go for this solar, rooftop solar or ground mounted solar if they have a space. When they have a solar, means the problem is like means already we are quite a lot of using quite a lot of nonlinear loads, and that injects the harmonics to the systems. And solar, this is intermittent in nature. This is available only in the daytime, but means probably your peak tariff might be in the evening, that is evening 6 to 9. So that's another factor. That means solar is not going to support you on the peak hours, but it is going to support you on the normal hours. Is there any possibility to shift the energy which is generated by the solar from non-peak hours to peak hours? Is there any solutions to address the poor power factor caused by the loads by means of adding reactive power compensation or something? Then how to maintain the peak demand which we have, how to manage our demand less than the peak demand, either to cut short the load, etc. One simple answer is like this battery energy storage systems. This is also called as microgrid. And let's take another case study as well. If the grid fails, assume that I mean, so to say, this PCS and energy storage. That PCS is basically a power conversion system, bidirectional converter with an energy battery energy storage. So assume that this is not there. If the grid fails, do you think that the solar will generate the power? Assume that this load is say 300 kilowatt and the solar is also installed with say 400, 500 kilowatt capacity. Do you think that means in absence of the grid, the solar is able to generate the power? If not, why the solar is not able to generate the power when the grid is not available? So these are the questions. The answer, simple answer is energy storage. So the energy storage with VSC based voltage source converter based bidirectional converter is able to provide a voltage reference. That means the system can work with the grid. When it is working with the grid, this energy storage PCS offers quite a lot of advantages. To name few advantages, like it can be used for a peak saving, it can be support for a spinning reserve, it can helpful for a power quality, it could help for means power factor corrections, and so on and so on. And this can also use to shift the solar which is generated on the daytime to the night, something like that. And when the grid fails, as I told, the solar will trip immediately. This means this energy storage can provide a voltage reference because this PCS comes with a voltage source converter. This provides the voltage reference. So that the solar can still generate a power. And that means what to say, when it is operating in an islanded mode, means what to say, this PCS have the capability to regulate the voltage and frequency by means of consuming or injecting real and reactive power, and by means of controlling this real and reactive power independently. So let's probably quickly move on. What this energy storage can do? It can do renewable farming. That means when this solar is doing an intermittent power generation, if I want to smooth out this renewable generation from the intermittent resources, that's possible. The one advantage of energy storage, it can do the renewable farming. It can do reactive power control. As I told, it can do peak saving. That means probably the solar will not be there at the night time, but your demand will be at peak for a commercial buildings from evening 6 to 9. That's why the tariff is higher. So if you want to reduce this peak shaving, it means if you want to cut short the maximum demand which is going to the grid, probably you can store the energy which is generated by the solar in the daytime, and probably you can use it from evening 6 to 9 so that the peak demand on the peak hours can be reduced. So that's possible with this peak saving applications. Ramp rate control is possible. That means at what rate this solar penetration has to come in, or means if we have a diesel generator or something, means at what rate this diesel generator has to ramp, and whether it is compatible with this diesel generator capability, etc. That very well we can validate this. This PCS. Similarly, it can do active power management, and it can do means independent real and reactive power control. It can do a spinning reserve. It can do inertia. What to say? When the system is operating here, let me come back to the slide. When the system is operating without grid, you have only power electronic devices, right? Means the power electronic device, the drawback is like this doesn't have any inertia just compared to this conventional synchronous machines. So this PCS can add a virtual inertia that provides stability for the systems. That's possible with this energy storage. It can provide a seamless transfer when the grid fails. Now in our college, we might be having a diesel generators. If the grid fails, we lose the power supply, then probably with the help of ATS, automatic transfer switch, or ATS. So, or probably auto main failure you might be having, AMF. This switch on the diesel generator, and probably within 20 seconds we are getting the power supply, but there is an interruption, right? If you have this energy storage, then you can have a seamless transfer. That means even if the grid fails, the customers or the critical loads will not have any interruption in the power. So similarly, the other important aspect is like here, when you're operating in a grid mode, there will be a huge fault current because of this utility source. But when you are islanded systems, that means only when you're operating with the solar and wind, means these are basically power electronic devices. They have a limited overload capability. So they inject only very small short circuit current. They inject only very small short circuit current. And that current may not be sufficient to discriminate whether it is a fault current or a full load current. So when we are not able to discriminate, your protection systems face a problem. When we are moving towards more and more renewables and power electronic based resources, that's another concern, like fault current, how to detect the fault. That's another big challenge. So this bidirectional converters with the VSC has a capability to inject at least a 2 per unit short circuit current. It depends upon the manufacturers. So that provides a discrimination between full load current and short circuit. Similarly, shifting, I think, which I have talked, the energy which is generated from the daytime that can be shifted to meet the demand at the night, that stores the energy in the battery in the daytime when solar is available and supply back to the night when the load is available. And standalone, this is an additional feature. As I told, if the grid fails, your solar inverter cannot work because that needs a voltage reference. And that voltage reference can be provided by this. The voltage reference can be provided by this voltage source converter based energy storage device. Yes, how we need to size this energy storage or microgrid? First, you need to do commercial evaluation. Then you can size the capacity of individual equipments optimally. You can do technical feasibility. Then you design and implement. What are the softwares which helps to do that? You have simulation softwares like Homer Pro, Homer Grid, Reapt, Plexos. So Homer Pro and Homer Grid, about 21 days trial version is available in net. You can download it. Reapt is basically an internet-based tool. This is not a software which is available forever. Infinite time you can use. And Plexos is another commercially available software to do the evaluation of economic benefits. That means it sizes what is the capacity of PV which you can go, what is the capacity of wind you can go with, and of course what is an energy storage which you can go with, what's the battery rating, or whether to go with the different combinations like wind and solar, or go with only solar, all these things which you can evaluate. So these are some quick, manufacturers of bidirectional converters, the batteries, balance of plant. This is complete layout of it. Technical evaluation, you can go with some simulation softwares like ETAP or Excel Power Factory or PSSC to evaluate, means what is the selection of the equipments is right or not. You can perform analysis like load flow, short circuit, protection coordination study, grid integration study, and most importantly, like transient stability, which you can do to evaluate what's the technical feasibility of such a systems. And probably this also means on an overall, which helps you to come up with the means right size of battery energy storage systems, which is just not commercially feasible, but also technically it is a viable solution. So techno commercial is the key when we are talking about this. I think what to say, with the help of this simulation tools, when you analyze using commercial evaluation and the tools which I have shown like ETAP, Excel Power Factory, PSSC, etc. So you will be able to provide really a good techno commercial solutions for this battery energy storage systems. That might be a very quick, very fast overlook of how the energy trends, which is going to be there in the future, and even sometimes at the present. And what to say, I'm happy to take a questions. If there is any questions, yes, please post me. Probably you can even unmute yourself and you can ask the questions. So there is a question from Kes. So Prabhu, what kind of power management system is supervising microgrid, whether conventional SCADA or advanced? Yeah, SCADA is a supervisory control and data acquisition that has a time delay. Means you need much sophisticated data acquisition and control systems so that you manage real and reactive power so that the frequency and voltage is regulated. So there are quite a lot of microgrid controllers which operates, and even there are some advancements which we are discussing, like have a combined control plus protection. That means protection needs very fast, right? It means protection operates in 1 cycles or 2 cycles. So that definitely makes sense. So means we have a sophisticated microgrid controller systems. When I say we, I mean it is almost all the manufacturers across the globe, those who are manufacturing this battery energy storage systems along with this microgrids have the microgrid controller. Yes, how can we reduce e-waste? I really do not know. Means that's the biggest question to be answered, Kumar. That's really a big question. That's a big challenge as well. Even when I'm promoting this renewables, what to say, that's really, what to say, really a difficult call of, what to say, how do we manage this? How do we manage this e-waste? Means we are growing in the renewables, but we do not know after the life of 20 years or 25 years what we are going to do with the solar panels. We do not know what we are going to do with this wind turbine generators, their blades, and we really do not have an answer. How do we are going to handle this lithium-ion battery e-waste? That's another big challenge, right? At least lead acid means you can recycle about 90%, but lithium-ion we don't have a clue. To talk about this lithium-ion, what to say, proper handling of the sea waste. There was a tender which we have worked in Australia. Means there was a price first quoted by the manufacturer with, say, example, take X rupees. And when we have revised the tender specification that after the life of this lithium-ion battery, means he has to take back this lithium-ion battery and he has to safely dispose it, and this is a responsibility of the manufacturer. When we have added additional requirement, then the price has increased from X to 3X. That means, what to say, still even from the manufacturer side of lithium-ion batteries, so what to say, lot of work has to do when we talk about with respect to the safe disposal of like lithium-ion batteries. So at present, yes, we are pressing the pedal of acceleration towards the lithium-ion batteries and energy storage in a large scale, but that definitely not a sustainable growth if you are not really addressing this point. Yes, very well valid question. That's where we are working, but as such means there is no commercially viable solutions. That's a really good question, Kumar. How this microgrid system varied from smart grid systems, Kesav Prabhu? That's a beautiful question. Yes, so that doesn't have a transmission network. That's one important difference which I can see. Smart grid consists of generation, transmission, and distribution, and its smartness is added in generation as well as the transmission and distribution. Microgrid is the small piece is microgrid. This small piece is microgrid. That means it has a generation, it has a consumption, it has an energy storage, which has a control, renewables. That's it. It doesn't have any transmission. Microgrid means a college campus or a hospital or a data center which has its own generation, which has its own demand, and there is no transmission network available. That's the difference between smart grid and microgrid. And microgrid is also means essential when you talk about smart grid. Smart grid, there are quite a lot of technology which you need to talk about, like SCADA, PMU, self-healing, auto reclosers, like bidirectional control of power, communication, IEC 61850. There are many technologies which you need to talk about. So microgrid is also one among the many technologies which is part of smart grid. And microgrid is basically only for distribution system where we are embedding the generations and we are trying to make that particular entity as a self-sustained one with respect to the generation and demand. Even when the grid fails, that can meet the local demands. And this microgrid also helpful where you cannot extend the electricity to the remote villages because of the distance. In that case, also this microgrid supports. That's called islanded microgrids. Yes, thank you. And there's a question from Rega. How are we going to control the reverse power flow when it is integrated with renewable grids? I mean, when we talk about the reverse power, that's not a constraint at all. I mean, what to say? We need a bidirectional power. That's about renewables, right? I mean, so what is it? When we talk about the energy storage, that is a bidirectional power. When we talk about smart grid, we need a bidirectional power. So reverse power is not always nothing wrong with that. Reverse power is not a constraint at all when you handle it properly. And this reverse power is only issue when you have a physical generators. Means a physical generator cannot handle a reverse power because the generator becomes a motor. For that, you have a reverse power release. Niti Kumari, sorry, I think Sunil Satish. Any chance of DC in future? I think I have to strongly recommend one video from one of our professor in IIT Chennai, right? DC grids by our IIT professor, right? You can get some good, very good videos on that. Probably I will share it. This yes. So even this is a very short video. You can find out another video also. Means people are working on DC microgrids, but means it's a long way to go. Means as on today, means we couldn't really make a commercial DC microgrids. But there is a research which is on with respect to this DC microgrids. People are working on, as Professor Ashok Jhunjhunwala put up. He has able to reduce the cost of electricity for a DC microgrids, remote islanded microgrids for a villages with an electricity cost of less than 18 rupees per unit. So that's really an achievement. Which the link which I have shared, which you can watch. Any difference between DC capacitor and battery systems? Battery, you can store the energy for a longer duration, but capacitor it is for a very short duration. That's a big difference. The battery you can store it even for a few hours. That's the answer, Keso Prabhu. Yes. Any other questions which I have missed? Probably you can. Yeah. What kind of power management systems for supervising? I think I have answered that question. Yeah. What's the development of energy storage from last decade to recent? I think what's the energy storage system which I have talked about with the image slide means you have a bidirectional, quite a lot of bidirectional controllers from various manufacturers. Nowadays, you can see at least 10 different manufacturers across the globe are working in this bidirectional converter. So that's a great change, and means the battery cost has drastically came down. Lithium-ion battery from $1,000 per kilowatt hour to now even 200 or even less than $200 per kilowatt hour. So means that's a drastic change. But apart from that, of course, there is always a research which will be going on the power electronics and other stuffs. Yes. What is anti-islanding in grids? Okay, that's great. So there is something called IEEE 1547 anti-islanding scheme. If I am going back to my slides, means what to say, if the grid fails, means what to say, or probably assume that means what to say the grid operator who is operating here, means what to say, want to take out this transformer for a maintenance, and if he is stripping this breaker and expecting that means what to say he can do the maintenance in this transformer, and he's doing the maintenance, then probably means what if you have a sources and if you are still connected to the system, this transformer might be energized from this reverse direction, right? So that means previously when there is no sources here, this is a radial network. If he just trips this and he can take this equipment for a maintenance, but now because of this solar or wind or energy storage or etc, Means there is a possibility that even after this getting disconnected, probably this equipment can means what to say feed in the reverse direction, so that this operator may think that means this is isolated or this is dead, but that is live from the reverse direction. There could be means what to say that is dangerous to work with that scenario. So probably means what to say anti-landing or IEEE 1547, that's the standard which we are talking about. That basically talks about providing a solution with an anti-landing, which means if the grid fails, you need to means what to say switch off or trip all the renewable intermittent sources which are connected downstream. So exactly anti-landing or IEEE 1547 anti-landing is exactly opposite to what I have talked. So means you should not get islanded means without the knowledge of the utility. So that's the anti-aliasing scheme. Probably you can refer IEEE 1547 for more details. And I think 2 more minutes I have. I can take one or two questions. The future lead acid batteries as an option for storing energy in microgrids. No, really. I mean, sort of say yes. People came up with a few changes and modifications, betterments in the lead acid batteries, but still I couldn't look lead acid battery as an alternate. It's not an alternate. And means if that is it, probably let me take only 1 more minute to talk about one important information what we can offer. So there are about 7 softwares like Homer Pro, Homer Grid, Reup, that's for microgrid design, Dialex, Evo, and Dialex, that's for lighting design, PV Syst for a solar plant design, grid connected and standalone plant design, including DC microgrids, ETAP and Excellent Power Factory, that is. Yeah, sorry, I think I got disconnected. Yeah, sorry. I think I got disconnected. That's from my end. Might be poor network, right? So the last point, what I'm talking about, we are coming up with an event called Enrothon. There are many partners, different 5 online competitions, 20 country expert speakers talking about United Nations Sustainable Development Goals, and there are panel discussions which are expected. So you can very well means join this event, which is going to happen on 8th August. And other event, I'm not sure whether when I'm presenting that I am live or not. This is another event exclusively for a student internship, which I'm going to which I'm going to talk about. Means 7 softwares, about 24 days, about 100 hours. We are going to cover different interesting topics. And because of time constraint, I'm going to not talk much on this. That informations will be available in the link which I am sharing, which anyway you can take and you can just really means look into that. Yes, and that's it from my end. There is a big thanks for all of the participants, those who are listening for the past 1 hour. I know that it's a big rush because of a time constraint. I put up quite a lot of informations, but I believe you will be able to take at least maybe means few percentage of what I have delivered. And if it helpful for you, and if last 1 hour is not a waste of time, then I will be grateful. Thank you, and I have to personally thank college management and Department of Tripoli for giving such a wonderful opportunity. Yeah, thanks. Special thanks to Sundaramurthy sir for giving such an opportunity in a big forum. Thank you, sir. And I'm stopping my sessions. You can take it up further.
Thank you, sir. I request our
Thank you.
department faculty, Mr. R.
Once again, sir.
Sundaramurthy. I request the department faculty, Mr. R. Sundaramurthy, to deliver FTP report. Please, sir.
Before that, I would like to thank you so much, sir, Mr. S. Selvakumar, sir, for giving outstanding presentation and excellent interaction with the participants. The way
Thank
you
you.
explained in the presentation simply exemplary. When we watch film, climax is the most important part. So our last day FTP session completed with your presentation. Thank you so much, sir.
Thank you. Thank you.
So first of all, I thank you all for giving phenomenal response for the past 5 days. This faculty development program intends to provide about recent advancement and technological developments in the field of electrical engineering. The major objectives kept in mind while framing the FDP were as to know about recent research in electrical engineering, facilitate to do research, enhance analytical skills, to understand the applications of a right tool techniques to do research. We hope everything was reached in the past 5 days. The program was attended by 155 participants, out of whom 148 participants from all over India. Now I would like to summarize the past 5 days report. Mr. Selvakumar sir also explained about for the past 5 days program. As a coordinator, I would like to say few words. The day one session was handled by Dr. A.S. Ramareddy, Dean, Triple E, Rajalakshmi Engineering College. He connected things starting from basics of electric vehicles and described various techniques involved in vehicle technology. Day two session was handled by Dr. A. Deepan Chakravarti, Assistant Professor, Department of Triple E from Barnariaman Institute of Technology. He has explained about research-based StatCom in distribution systems. And day three session was handled by Professor M. Vijay Kumar from EGS Pillai Engineering College and the Director of Consultancy Services. He focused on several points related to product development and Arduino controllers. Day four session was handled by Dr. S. Shivakumar, Department of Triple E, Professor, King's College of Engineering. He started with the cylindrical process of research and explained about multi-objective genetic algorithm. And today, the day five final day was handled by Mr. S. Selvakumar sir, Head Engineer and Design Power Projects in the titled Role of Energy Storage System in Future Power System. I think he has covered the entire analysis of energy scenario of power systems. So on behalf of the Department of Triple E, King's College of Engineering, I thank all the resource persons who accepted our invitation for enrich their knowledge in all the 5 days. Thank you. I also thank all the active participants, especially Mr. Keshav Prabhu sir, Palani Kumar sir, and PV Charanteja sir for interacting every day. Thank you so much.
Thank you, sir. Thank you, sir. I request our Professor Dr. S. Shivakumar to deliver valid address. Welcome you, sir.
Out.
Good evening, participants. Hope I am audible to you. Now, these 5 days, of course, for all the electrical engineers, various inputs have been given. I think someone has. Okay, now it's okay. These 5 days, of course, various inputs have been given for the electrical engineers, right from varying topics like e-vehicles, StatCom and distribution side, Arduino processor, and then the mechanistic genetical development, and then today it's energy storage system for future power system. So all these inputs are very, very relevant to the technical topics, to the engineers. I hope 1 hour per day may not be sufficient to make you understand the whole concept, but I can certainly feel that this 1 hour has thrown some certain light or some light on the particular topic or issue. Now it is the duty of the participants to go deeper in those particular area and learn more about that. If you have done that for your own welfare, I think the success of this workshop is time. I wish you all the best for all the participants. Hope you have enjoyed the today's program and you will be supporting us for the future programs which are planned by the technical department of our King's College. My special congratulations and thanks to all the resource persons who voluntarily given all their effort for the betterment of daily life in society. Thank you all. Thank you. Thank you very much.
Thank you, sir. Thank you very much, sir. If any of the participants want to give you feedback about the 5 days event, kindly unmute your mic yourself and deliver your feedback. If anybody participants want to give a feedback, oral feedback, please unmute your mic. Okay, thank you. Then some instruction about the participants. So dear participants, we kindly request you to submit the 50-day feedback. We provide e-certificate to the participants within a week. Those who having 60% and above attendance, it means a minimum of 3 days feedback submission. We will send you to respective mail. The PPT will also be sent to your WhatsApp group. If you have any queries regarding FDP, send WhatsApp message to the coordinator. They will do the needful to you. Thank you. Now I request our head of the department to deliver a special thanks. Welcome you, sir.
Hello. Hello, this is Albert,
Hearing,
Head
sir.
of Department Triple E. Hello.
Sir, hearing, sir.
Is it audible?
Audible, sir.
Okay. I think the 5 days FDP is very useful to all the participants. I thank all the resource persons and also I thank the coordinators of this program. So it's very useful to one and all participate in this program. Thank you all.
Thank you, sir. Thank you very much, sir. Now I would like to call our department faculty, Mr. J. Arikraj, to propose vote of thanks. Welcome you, sir.
I feel very happy to propose the vote of thanks for this 5 days FDP on recent advancement and technologies in electrical engineering research perspective, organized by Department of Triple E, King's College of Engineering. I would like to thank our management and secretary sir for provide such opportunities for us to us. On behalf of Triple E Department, I would like to propose the thanks our principal ma'am for his continuous support and opportunity. Then I would like to thank our Vice Principal and HOD Sir for this continuous guidance regarding FDP for all aspects. I wish to thank our resource persons for this 5 days FDP. On behalf of organizing committee, I would convey our special thanks to Mr. S. Sabanayagam, Assistant Professor, Mechanical Department of Mechanical Engineering, and also Mr. Niranjan Samuel, Research Assistant, King's College of Engineering, for their restless effort towards the
देख लेंगे
YouTube
डालना जी
training.
फोन करा था कांटेक्ट कट हो गया बीच में
We
कितने
consider
मैसेज आए थे नहीं चाहते हैं खाली
they are also a coordinator for this event. I thank our department faculty members for this kind support. I thank our student R. Divya Bharat, third year Triple E, for his wonderful effort towards the event. Finally, I would like to thank our all the participants for the continuous listening. We feel that like to happy journey with the all the participants for this 5 days FDP. Once again, I will thank to all for supporting this FDP program. Thank you one and all.